Black holes have always been the most terrifying objects in the universe, an abyss so powerful that nothing, not even light, can escape its grasp. But what if I told you that the very thing we thought was possible, crossing the event horizon, was an illusion? That something so violent lurks at the boundary of a black hole that it obliterates everything before it even enters. Recent theories suggest that black holes may not be the cosmic gateways we imagine, but rather fiery death traps where reality itself shatters. And here is the truly terrifying part: scientists may have just found proof that event horizons are not what we thought. For decades, we believed that if you fell into a large enough black hole, you'd slip past the event horizon without even realizing it. General relativity assured us that, from your perspective, nothing special would happen. But quantum mechanics, our other pillar of physics, screams that this cannot be true. Because if it were, fundamental laws, like the conservation of information, would be violated. And that is where things get disturbing. What if, instead of gently passing through the horizon, you were incinerated by a wall of pure energy? This is where the firewall paradox comes in, a concept so controversial that it threatens to rewrite our understanding of space and time. Imagine a force so powerful that it destroys anything that dares approach the event horizon, a raging inferno of quantum chaos, defying Einstein's cherished principle that freefall should feel smooth. This idea emerged in 2012 when physicists Almeri, Marolf, Polchinski, and Sullyes, they have an acronym, AMPS, realized that our assumptions about black holes led to an impossible contradiction. Either information is lost forever, violating quantum mechanics, or the very fabric of reality breaks down at the event horizon. Their conclusion? A firewall and invisible but deadly barrier must exist, turning anything that crosses into pure energy. And here's where things get even stranger. The idea of black hole firewalls is unsettling. It suggests that black holes don't behave as smooth, gentle curvatures in space, but as violent cosmic incinerators. But here's the kicker. Firewalls completely contradict Einstein's equivalence principle, one of the bedrock ideas of general relativity. According to Einstein, if you were falling into a black hole, you wouldn't feel anything special at the event horizon. But firewalls say otherwise. They say that instead of peacefully crossing into darkness, you'd be burned to oblivion in an explosion of high-energy radiation. So which theory is wrong? Quantum mechanics or general relativity? This is where the real battle begins. To understand why this is a problem, we need to talk about entanglement. In the quantum world, particles can become intertwined, means knowing something about one particle instantly tells you about its partner, no matter how far apart they are. This happens all the time in nature. But in black holes, entanglement takes on an even deeper role. When Hawking radiation escapes a black hole, it carries away information. If black holes obey quantum mechanics, this radiation must be entangled with both the stuff inside and the radiation outside. But there's a catch. Quantum entanglement follows a strict rule: monogamy. A particle can't be fully entangled with two different things at once. And that's where things go wrong. This entanglement dilemma led physicists to a shocking conclusion. Something has to give. Either the information falling into a black hole is somehow destroyed, which quantum mechanics forbids, or the entanglement breaks in a catastrophic way. And breaking entanglement isn't free. It requires an enormous burst of energy. This is where the firewall emerges. If information is preserved, then a burning high-energy shell must exist at the event horizon, severing entanglement before it can cause contradictions. This would mean that the event horizon is not a calm boundary, it's a death zone. But hold on, if that were true. Wouldn't it mean that every black hole we've ever studied is fundamentally different from how we imagined? This paradox has torn the physics community in two. Some believe firewalls must exist, even if they break Einstein's rules. Others think the whole idea is absurd. Stephen Hawking himself initially believed that information was lost in black holes, but later changed his mind, arguing that some unknown mechanism must be allowing information to escape. But if there's no firewall, how do we solve the paradox? This is where things get even more mind-bending, because recent discoveries suggest that black holes might not be what we think they are at all. And if that's true, then our entire understanding of the universe is in question. One alternative theory is that black holes don't destroy information, but instead store it holographically on their surface. This idea, called the holographic principle, suggests that everything falling into a black hole is encoded in a two-dimensional form on its event horizon. If true, this could mean that the firewall problem isn't as bad as we thought, because instead of a fiery death, information would simply be scrambled and slowly leaked back out. But while this sounds elegant, it raises a terrifying question. If black holes are holograms, is the universe itself a hologram too? Other physicists argue that space and time themselves emerge from entanglement, and black holes are testing grounds for understanding the very nature of reality. One wild idea suggests that what we call black holes might actually be fuzzballs, complex, tangled webs of quantum strings that replace the traditional singularity. In this view, there's no smooth event horizon to cross, because space itself is a seething mass of quantum information. If this is true, then firewalls might not be fiery walls of death, but rather a sign that space-time is breaking down in ways we don't yet understand. The search for answers has led physicists to look beyond black holes entirely. Some believe that studying the early universe, the conditions just after the Big Bang, might offer clues about how information survives extreme conditions. Others think that wormholes, yes, actual shortcuts through space-time, could be the key to solving the paradox. A bold new idea suggests that black holes might secretly be entangled wormholes, meaning that when information falls in, it's actually traveling somewhere else in the universe. If that's true, then black holes aren't endings at all. They're tunnels to something beyond. So where does this leave us? Firewalls are one of the most controversial ideas in physics. If they exist, they shatter Einstein's theories. If they don't, then something even stranger must be happening inside black holes. Some physicists argue that we need an entirely new theory, one that unifies quantum mechanics and gravity into a single framework. But whatever the truth is, one thing is clear: black holes are not the silent, passive voids we once thought. They are active, dynamic, and possibly the key to unlocking the deepest mysteries of the universe. For now, firewalls remain a paradox. No telescope can peer inside a black hole to see what happens. But future experiments, like studying gravitational waves and simulating black holes in laboratories, may provide new insights. Some scientists believe that when we finally understand event horizons, we'll uncover new laws of physics that rewrite everything we know. And if that happens, we might have to rethink the very nature of reality itself. But what if there's something even bigger, waiting to be discovered? What if black holes are not just cosmic mysteries, but the foundation of the universe itself? Some physicists suspect that black holes existed before the Big Bang, and that their strange properties might hold the secret to what came before time itself. If that's true, then understanding black holes isn't just about physics. It's about unlocking the ultimate truth of our existence. So, do firewalls exist? Are event horizons cosmic incinerators or mysterious boundaries leading somewhere beyond? Until we can probe deeper, the true nature of black holes remains one of the greatest mysteries in science. But one thing is certain, whatever we discover next will change our understanding of the universe forever. If you're fascinated by black holes and the mind-blowing secrets they hold, don't stop here. Check out our next video on what if infinite black holes are hiding in our solar system to explore the endless depths of space and the mysteries they contain. See you there.